This video is the supplementary prototype video, so we can show you roughly where we are right now and explain a little bit more detail how this system actually works. So, right here in front of me, we have got a long board, and just to say, I am aware that a fair few people watching this video are most likely either visually impaired, blind, or hard of hearing, and possibly some even completely deaf. Those are the two main disability types that we're looking at with this technology, and I'm going to go into a little bit more detail now about what this system actually does. So, putting it simply, this system is designed to collect information about your environment, process it, and communicate anything that it thinks you should be aware of as the wearer, the user. So if this thing detects certain things that you should be aware of, for example, a tree branch hanging low, a lamppost, a car coming towards you, it can tell you quickly. It can't guarantee 100% replacement for other disabled aids. That's not what this is for. It's designed to make your life easier. So, first and foremost, this circuit board in front of me, a lot of people are going to notice straight away there is a whopping great heatsink on here. That's this big metal radiator, and there's a fan running on top. Now, I will explain why it's necessary to have that on this prototype. That's because this board is doing a lot. Even right at this moment, even though nothing is happening, this is a very busy circuit board. It's running to its limits here, and if you have little microchips doing lots and lots of processing very fast, they're either going to wear out quickly, or the problem we've got, they get so hot they melt their own solder and remove themselves from the circuit board, and then the system stops working. That's what we're doing at the moment, miniaturizing this system so it fits into this box or smaller. This is not the final design, this is just a concept design. Now, while I'm on that topic, there are devices called AI smart glasses, and these are becoming more and more common. They are very, very clever and useful for people who have sight loss because they have camera built in, sometimes two, and they can take pictures on demand of something such as the sign on a lamppost or the front of a restaurant or anything else. You can take a picture of a scene and ask it to describe what you're looking at, which is brilliant, incredibly useful things. However, if like me, you are one of those people who is much further along in terms of visual deterioration, I'm beyond 90%, so I class as blind. My assistant has set this up for me and she's filming. This is Cassie, she's my associate, and she's got the pleasure of wiring up my circuit boards for me since I lost the ability to tell wires apart. I can still work by feel, but what we've got here, you will have, I'm sure you've got knowledge of artificial intelligence. Most people have heard of that these days. I'm sure loads of people are using it, some without even realizing it. If you've got smart glasses, and I'm not going to mention any brand names, if you need assistance from smart glasses, generally speaking, they all have something in common. They connect to your phone, usually by Bluetooth or Wi-Fi, and when you have the need to read something or get assistance, you'll press a button on there and they'll snap a photo, send it to your phone. Your phone then sends that to an AI data center, processes it, it comes back to your phone reads the response out to you via your glasses so you can hear it. So if I was walking down the road with these smart glasses, I snap a picture of a sign, it recognizes the text on the sign through the AI data center and then reads the text off the sign to me. Extremely useful. Let's give you another scenario. Let's say your issue is mobility in general. You need to move around. Let's say you're walking down a path, even if you are sweeping a white cane along the floor, or you are completely hard of hearing, deaf, and there's something there you're not expecting, such as an overhanging tree branch right across the path. Well, if you're blind, you're not going to see that. it's going to go straight in your face. If you're deaf, a lot of people think that if you are deaf, you can still perceive everything around you, even if your eyes work perfectly. Well, a lot of people don't realise when you're hard of hearing or deaf, you have a problem. Ears communicate to the brain to tell which way to look in. If you can't hear anything and there's a car coming from behind you, unless you're constantly looking left and right, turning your neck constantly to check roads, you're still disadvantaged in terms of being able to navigate hazards, because the brain depends on both seeing and hearing to have a good 360-degree idea of what's going on around you. Situational awareness being impaired like that causes a lot of problems. This is where we move on from the smart glasses, because there's a big problem with smart glasses. It's a limitation purely based on the design. Let's say that you are blind or deaf, you're standing waiting to cross a road. Because you can't hear cars coming, you're looking one way and then gradually looking another way. And because it's like living with hands over your ears, you can't hear noises like a car coming, bicycles, so on and so forth. You're purely based on what you can see. So you step out into the road because there's no traffic lights there, and you get a surprise. Same with not being able to see. Some cars these days are extremely quiet, like electric cars barely make any noise at all. And then you've got bicycles. A bicycle, I've been nearly knocked down by 2 bicycles in the last month, because very simply, I can't hear them coming. You can stand there for ages at a crossing. I'm not talking traffic lights. If you've got traffic lights, it's different. But if you're just standing waiting to cross the road and you've got a bicycle coming, not all cyclists give any indication that they're there. So you think it's completely silent, so you start to cross the road and there's a bike. They don't always stop. They will swerve and shout at you. So how can we solve this problem? Because AI smart glasses are useless in this situation. Why? Because they take so long. They only process image on demand. So if you're looking left at a crossing, you're waiting for the smart glasses to process that picture. By the time it's sent that back to the data center to convert it into information, whatever it can see is already expired. You could have been knocked down by a bike, a car, walked into a branch. By the time it's even sent that data to the AI data center to assist you. So that's a limitation. They're nowhere near fast enough. Now this design works completely differently. This is patent pending. The idea is it integrates into your everyday tasks in such a way where it becomes a part of your sensory system. It's an extension to your own senses. Just a generic webcam I've bought on the internet, and we've connected it to our system here just as a demo. And just to explain, we've got a bundle of wires coming out one end of the circuit board. These are going to, we've got a sound cable coming out, we've got other sensors going in, and then up the other end we have got a cable, data cable going to the laptop, which is where I am sending the image through. The final version, the one that this project is to help fund, will do all of that. You won't need it connected to a laptop. You'll just have lots of little modules that talk to each other using a high performance, low energy Bluetooth. And the system is going to recognize what I show it. Now, this version can be fooled by pictures such as this laptop screen. I've got on here a couple of different images. Now, I can't actually see what they are, so I'm going to have to ask my associate Cassie to assist here.
Yes.
Can you just tell me to stop when it's a car?
Car.
That's a car, is it?
Yep.
So is that a van or is that the red car?
It's a white van.
A white van. Well, if I now show this camera, which is connected to this board, no internet here.
Vehicle detected on left.
There we go. So, as you can hear, the board has identified there's a vehicle on the left. Now that could very easily be approaching you, and as I said, this will be combined with other sensor methods, including LiDAR and ultrasonic, to determine the angle, trajectory, distance, so it will be able to give you more information. It will say something like a car detected a certain distance away and it's approaching. It will also hopefully be able to tell you if it's stationary, so you'll have a bit more information at your fingertips. Now, you shouldn't rely on this system 100%. You should still use white cane or any other visual aids you have, but imagine that you're going out, you're potentially getting another lifeline there. Imagine how much easier it would be to cross the road if you've got a device telling you if there's any vehicles coming. Similar, if I now change to, I think
That's it?
I think that's a branch, isn't it?
Mm-hmm.
So this is a picture, I think, of an alleyway, and there's a branch hanging across, and it should recognize the branch.
Tree branch detected.
There we go. So, as you can hear, it's able to identify hazards and communicate them back to the user, but that doesn't stop there. It can also vibrate. So if you are hearing impaired, imagine you are wearing the module. Now the idea is that all of this, plus the camera, plus a certain amount of what the computer's doing, will be built into this. So you won't need to connect this to a computer or even a mobile phone to use it. It's a self-standing system, it's a standalone system. What it's going to do is it's going to recognize objects using the camera. I've just drawn a little circle roughly where the camera might be. There'll also be one in the side. So, because if you imagine you're wearing this on your wrist, I'm just going to quickly put that roughly where it would be. If you imagine you're wearing this thing and you're walking along, that's there. You're walking along, your arm's moving. You're not going to be walking along like that, holding the camera perfectly still. This is moving. The AI in this, the onboard inference processor, which is doing tons and tons of work every second, and that's why the chip gets so hot, and that's why on our prototype we've got this big fan. Final version won't need that. We've already looked into Intel chips, Intel FPGA chips, and high-performance ARM processors that we can use. We've also been looking into Broadcom's range. We mention those three because factual integration of the technologies that they are providing chips for into our system should allow us to miniaturize it and let it run reasonably cool, allowing it to run off a small battery. This thing, you can see, is currently drawing 16 watts of power, and it's generating a reasonably high amount of output in terms of heat, and that's why we have to cool the chips down so they don't desolder themselves from the circuit board. We're using a big chunky battery here to power the board. You couldn't walk around with that on your wrist, so this is being miniaturized. Now there's no risk involved with that because we've done it before. We've done stuff like this in the past, and the main thing here is the reason we're on Kickstarter. We need to know how many people like the idea of this system as a visual aid or a sound aid to allow them to interact with the world. This thing will also vibrate. So imagine it detects something. It can't communicate to you by sound. In the future, it may put up a visual message on a pair of glasses, but it could also, for the time being, vibrate to let you know. But here's the good bit. To make this thing universal, we've also, from the outset, as in from the very first prototype here, we have designed this with a mode switch. So if I press the mode here,
Idioma seleccionado español.
you've got Spanish. So what we've done is we've just changed the language to Spanish. So let's, I think that's a car.
Yes.
You'll have to excuse me. Okay, yes. So if you were to show your device to the car or whatever, it will detect it. This, as I said, is just a box. So if I show the actual system using this mock-up with a camera.
Vehículo detectado a la izquierda.
So you can use this system even if your language is not English. We've also got Mandarin Chinese on here.
你选择英语。
Let's do a randomly selected one. I think I've ended up on the same, I'm not sure.
左侧检测到车辆。
Okay, so it's, as you can see, it's managed to detect that every single time, but then again, those images it's used to because I've been
左侧检测到车
doing
辆。
tests. So this thing should be able to detect the majority of cars, vans, bicycles, other forms of transport as well. It should be able to detect lampposts, pillars, and combined with the other capabilities that will eventually be built into the ankle straps, you'll be able to detect curbs, dips in the ground, mud, puddles, all sorts of stuff. The glasses are going to take longer. We don't know if the glasses will be released in the first version. If you look in the rewards for this project, you can see we've got various different rewards there. But when we say prototypes or a final version, we're talking about a basic version, won't necessarily be fully functional. What we really want is we want to integrate support for thermal detection as well, so that you can put it onto cooking mode. So I had a language mode button there. The next version along will have a automatic mode, and it will detect what you're doing and be able to switch into a useful setting for that. So if it detects that you're in a kitchen, for example, and it detects that you're trying to cook something, it will go into thermal imaging mode, and it's going to be looking for safety hazards. And if, for example, you're doing some cooking and you've accidentally left the gas on with a light or something, it should hopefully be able to detect the presence of hot metal or a flame and alert you before you put your hand on it or walk out the room and leave it unattended. Stuff like that. Be very helpful. We've also got Parkinson's. We've mentioned Parkinson's disease very briefly in our other video. You probably think, why have they mentioned that at all? Well, over here on this end of the board we have got a series of MOSFETs, which are like a circuit board's way of turning things on and off. They can be used to control stepper motors and other things, speed controllers and stuff like that. So they've been around for a long time. It's nothing amazingly new. What is interesting is the way that our system is able to use these in such a way that by combining it with another module in the future, we may be able to stabilize a person's natural tremor. Parkinson's disease caused by neurodegeneration. A person's nerves deteriorate to the point where they can't control what they're doing. If you imagine they're trying to have a drink, they're trying to pick up a glass of water, they're shaking it. It's the same with the walking. We've actually been asked about this illness in the past, and we tried to find ways to integrate it. So we're still looking into that, and if there's more requests for that, we'll certainly prioritize it. But for now, our first prototype that we're working on and seeking funding for is primarily aimed at visually impaired and audio impaired users. If you'd like to support this project, then we thoroughly appreciate your contributions, both ideas. If you're willing to pledge, that's wonderful. This is the current state of the project, but we do already have designs for the next version, which is scaled down. Doesn't require a whopping great big fan and heatsink to be running on it. And yeah, it's incorporating a lot more information, so it can't be fooled so easily by a picture on a screen. You get more interesting feedback, and as I mentioned, the design is patent pending, but the name and trademark is still in progress arrangement, so we don't have a name that we're releasing for it just yet. If you want to get in super early, as this project is just building traction, this is your chance. And we look forward to your suggestions. So we've already got the languages, as I mentioned, English, Mandarin Chinese, and Spanish, because those are the 3 languages that are most commonly spoken. But if we get requests for other languages, we may look into it or consider adding those if we can fit those languages into the programming. I've got a team here assisting. My associate Cassie helps me with things, so although, as you've probably noticed, I can't really see much of what I'm doing, I'm able to find and navigate my way around. There's not really any limitation on our ability to develop the project, and the only risk associated with backing this project is how long it's going to take to develop it. But we usually estimate things over. So if we say 2 years, hopefully we'll be delivering it sooner. I hope you have a pleasant day, and